Hi, this is Dr. John Bergduff. In this video, I want to show you some very nice but very simple manipulatives and tools that can be used to illustrate the concept of whole numbers and particularly whole number addition at a very basic level. We're talking about kindergarten, first grade, some very great tools. So just as a reminder, the whole numbers are the set of numbers that begin with 0 and count 1, 2, 3, 4, and continue on and on forever and ever and ever. Let me show you some of my tools or manipulatives that I have. So one tool that I want to show you is this tool is called integer chips. Now, integers imply that later we're going to be looking at positive and negative numbers. These are nothing more than black circular pieces that can be used to count and illustrate. You can buy directly from manufacturers, some designed for classrooms. These are just poker chips. Now, there's a reason why I'd like these to be black. So when you're talking about whole numbers, particularly talking about counting numbers, use black chips. The reason for that is later when we talk about the negative integers, we're going to use red chips for those. So the color coding is kind of important. So young kids can get the idea of counting whole numbers simply by counting these chips. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so forth. They can also get the realization that this is 3 chips. If you spread them apart, it doesn't change the number of chips. That is actually a developmental issue that takes a little while for children to develop. It's tempting to say that this is more than this, but by handling these and realizing it's the same number of chips no matter how you move them around, that helps reinforce that sense right there. Also, very, very simple way to illustrate addition as the idea of putting together. So let me back up here a little bit. Addition, putting together. So it's very easy for very young children to explore what happens, for example, when you add 2 plus 3. You got 2 chips, 2 of these black integer chips, and 3 more, and putting them together, 1, 2, 3, 4, 5 just creates 5. And very simple to play with that as much as little kids might like to. So those are integer chips, and that's one nice little tool or manipulative that can be used. One of my absolute favorites are called, these tools that I'm going to show you next are called Cuisenaire rods. They are named after the educator who came up with them. And these are simply colored rods. They are great for getting the ideas of counting the numbers, and they're great for addition. Here's just a whole bunch of them. Probably more than I want. We'll look at that later. So the cool thing about these is that each one of these rods, and I'm going to try to show it up closer to the camera so maybe you can see, is marked off in units. And get the light on that just perfect. You'll see it better. Yeah, that's pretty good. So each color represents a different number that you can count. So little kids can get used to counting. And for example, this one has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this rod represents the number 10. I'll just put that over here. That's a 10. And this one here, try to get the light on it just right, represents 4. 1, 2, 3, 4. So that one's 4. And you have every imaginable shape. All of these all of these represent the numbers between 1 and 10. This is obviously 1. That was 10 we saw over there, and we can see every other value as well. That one represents 3. And notice that they are designed to be put together, which is awesome for teaching addition. Let me make a little bit of space here so I can do this. Suppose, for example, you want to illustrate what 3 plus 1 is. Well, you can take the little rod that represents 3. So again, oh, there, now you can really see it. See the 3 marks there. Take the little one that represents 1, and adding them literally means putting these together. And then exploring what that's equal to means finding the piece that has the same length. So again, let me hold that up really well. And I can see here that 3 plus 1 is equal to 4. I can explore other operations, whichever ones I want. Let's say let's say we want to do 2 plus 7. So the task here will be to find the rod that represents 2 and the rod that represents 7. And you just got to find it. That one's 8. 1, 2, 3, 4, 5. So that one's 6. I think maybe it's this one. 1, 2, 3, 4, 5, 6, 7, 8. Nope, that one's 9. Aha, it must be this one. 1, 2, 3, 4, 5, 6, 7. So if you look very closely, get just the right line on it. You can see that that represents 7. There. Now I finally got it. You can count the little marks and see that that represents 7. And you can explore what 2 plus 7 is and find what it matches up to. And if I remember right, this was, nope, that was 8. Let's see, I think I'm missing one. This is not, no, that's 10. That's, all right, I'm missing one. It's in here somewhere. Well, maybe it is this one. 1, 2, 3, 4, 5, 6, 7. Oh, I've miscounted. That's 9. And that adds up. 2 plus 7 is equal to 9. And you can count on there and see the 9 little marks. So these are great. Little kids can just practice addition facts of different kinds by putting them together and matching them up, whatever problems they want. Cuisenaire rods are really great for illustrating a number of facts about addition and also subtraction later on. So I really love those. Those are nice. They are actually patented, so the colors are patented. You can buy paper versions of these fairly cheaply, or you can buy the actual manipulatives, which are kind of fun to play with. So another nice way to illustrate whole numbers and ultimately addition is using a number line. And this is a far more well-known system where if you want to represent, say, the number 7, you simply count it on the number line and draw an arrow maybe. Actually, some people like to draw the arrows horizontally across. I kind of like them to go up in the air like that. This would represent the number 7. And these are excellent for teaching addition and other operations, because if you have an addition like 7 plus 3, it simply means go 7, and then from where you left off, go 3 more, and see where you land. So we see that 7 plus 3 is equal to 10. Very, very nice. So say I wanted to also illustrate, I don't know, 8 plus 6. This is something that your kids can just count. You go 8 from 0 to 8, and then you go 6 more places. 1, 2, 3, 4, 5, 6. And you simply count one arrow followed by the other, and that lands you at 14. They actually make great big number lines that you can put on the floor of your classroom, and kids can walk them. They can actually walk from 0 to 8 and then walk another 6 places. And that really, really, really makes it very kinesthetic and is really great if you need to have the kids blow off some steam. So 3 tools: integer chips, Cuisenaire rods, number lines to represent whole numbers in their addition. All of these tools can also be used to illustrate some of the important properties of addition. For example, we know about, or have talked about, or will talk about the commutative property of whole number addition. And I'm going to show you how this could be done on any one of these, illustrated on any one of these manipulatives. The commutative law says that if A and B are any two whole numbers, then A plus B equals B plus A. Or in other words, the order of addition doesn't matter. You can change the order and you don't change the answer. If you are having trouble with your students learning the word, commutative comes from the word commute. And if you think about commuting in day-to-day life, especially if you live in a big city like Houston, commuting means moving around. So this is telling you that you can change the order. You can move things around and the result doesn't change. Let's say you wanted to illustrate that 3 plus 2 is the same thing as 2 plus 3. Here's how I can illustrate that with my integer chips. Here's 3. Here's 2. Here is 2 plus 3. Different operation, different order, but it's very plain that 3 plus 2 is the same thing as 2 plus 3. So reversing the order doesn't matter. One other little quick thing before I leave this and look at some other things. Sometimes people mispronounce this word. It's sometimes pronounced like commutative. And that is particularly the case here in the South, where we tend to go a little soft on our consonants anyway. So commutative, commutative don't really sound all that much different. Commutative comes from the word commute, which is moving around. Commutative comes from the word commune, and that means, you know, getting together and sharing, and or if you wanted to really freak out your kids, you could talk about how that represents communism, and we all think communism is a really horrible thing. So so commutative, communative, and again here in the South we pronounce them nearly alike. So integer chips are wonderful ways, there goes one to the floor, to illustrate the commutative property. Another way to illustrate them that is super nice is to use these Cuisenaire rods, because you can have the operation left to right emphasize order and show that you get the same thing. If I look at these two pieces here, the pink one is a 4, the yellow one is a 5. So this is an illustration of 4 plus 5, whereas this is an illustration of 5 plus 4, and it really shows that there is something different that goes on there. It looks different. 4 plus 5 looks different from 5 plus 4, but the important thing is that the result is the same. I can match them up with each other and show, yes, that represents the same length. Plain as can be. Very, very nice for illustrating the commutative property. You could also use number lines, and that also is really clear. Let's use the same 5 plus 4 and 4 plus 5. The first number tells you your first arrow. You always start at 0. So 5 plus 4 looks like this. But if I also want to consider 4 plus 5, I can put that down here. 4 plus 5. The arrows look different, but you end up in the same place. And that illustrates the commutative property, the property that says that you can change the order of an addition. The order doesn't matter in addition. You get the same result. So nice manipulatives, nice property. There's another property that's super important for whole numbers that all of these manipulatives are great at illustrating, and that's the associative property. Associative comes from the word associate. And so if you think back to being a kid yourself and remembering your mother possibly saying, be careful who you associate with, this is going to give you a real solid idea of what this property means. So in this case, you're looking at three numbers. If A, B, and C are any three whole numbers, then A plus B plus C in parentheses is the same as A plus B in parentheses plus C. What that's saying is, if you have the three numbers, you can add the second two first, followed by the first, or the first two first, followed by the third. And either way, you'll get the same thing. Let me illustrate that. Again, we're going to use all the same tools. So suppose we have 3 plus 5 plus 2, and I wanted to use integer chips. So the parentheses would tell me that I'd start inside the parentheses first, and I'd think about 5, 1, 2, 3, 4, 5, plus 2. I kind of go off the paper a little bit, but that's okay. That's 5 plus 2. Adding the 5 plus 2, and here we can count, will give me the 7. 1, 2, 3, 4, 5, 6, 7. The parentheses mean do that first, then you would add in 3. 3 plus 5 plus 2, and since the 3 is first, I'm going to put it up above. 3 plus 5 plus 2 would look like this. I already have the 5 plus 2, and then I add in 3 more, and then I can count by putting them all together. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I'm going to push those away and remember that I got 10. Then I'm going to start all over and say, well, what would it look like if I put my grouping symbols here? So I'm changing who's associating with whom. This would say add 3 plus 5 first. So 1, 2, 3, and 1, 2, 3, 4, 5. Get out of the way, you guys. 3, 4, 5. 3, 4, 5. And push them farther out of the way. This is 3 plus 5. Doing that operation first will get me a total of 8. I can count those and see I've got 8. And then I would add the 2. And that gives me a total of 10. And even if the kids are not terribly good about counting yet, and that's fine, you have the 10 that you created before, and you can simply just make sure that they count the chips in both piles, and both times they get the same number. So the integer chips can be great for illustrating the associative property, coming from the word associate. The Cuisenaire rods are awesome for doing the same thing. Let's do some slightly smaller numbers, because the Cuisenaire rods, the largest one is only 10. So we're going to use some smaller numbers so we don't run out. So let's say we're looking at 2 plus 5 plus 3. And then later we'll look at 2 plus 5 with the parentheses around the 2 plus 5 first. We have the parentheses mean do this first. So I am going to find the Cuisenaire rod that represents 5. 1, 2, 3, 4, 5. And the Cuisenaire rod that represents 3. 5 plus 3. So I would add those together first. You could illustrate what just that does for you by finding another rod that has the same length. Yellow plus green equals brown. So my 5 plus 3 I'm going to replace with this. And then I'm going to add in 2. So I find my rod that represents 2. It's written in the front, so I'd like to put it on the left. 2 plus 5 plus 3. And now we can count up and see that the result would be 10. I believe that's my 10. Yep, there's my 10, the orange. So I saw that I added the 5 and the 3 first to get the 8, and then I added the 2, and the result was 10. On the other hand, if I group differently, we're going to see different pieces, and we're going to see different ways of grouping things, but in the end, we should get the same answer. So let's kind of leave this where we can see what we did already the first time. 2 plus 5 would mean we'd start with the 2, and there's the 2, and then we'd find the 5, and that's this yellow one. So there's 5, 2 plus 5, doing just that first. That will match up to something. I believe it's the black one. Actually, both you and your kids very quickly will figure out which colors are which. It's very visual, very nice. That gives me 7. So put that up here where you can see it. Black one's harder to see. So 2 plus 5 is 7. I'm going to replace that. And then I'm going to find the Cuisenaire rod that represents 3 and add that on. And notice I'm putting this one on the right side because the 3 is on the end. And then I match that up to see what that is. And the bottom line is whether I added the 5 and the 3 first and then the 2, or whether I added the 2 and the 5 first and then the 3, the end result is the same. So who you associate in this case with doesn't actually matter. So that's looking at the associative rule with Cuisenaire rods. And guess what? Yes, we can finally do the same thing with number lines. Let's see. Let's do, I'm bored with those numbers. So let's say we have 4 plus 6 plus 3. The 6 plus 3 would mean do this first. So in the number line, you always start at 0 with your first jump. So 6 plus 3 would look like that. And here's where you would end up. It's not quite as nice as with the Cuisenaire rod where you can kind of show things in order. Here you have to always start at 0 and keep moving to the right. So your plus 4 on the end would start here and go 4 more. The green is 6 plus 3. And then the red adds in the 4. And you end up at 13. Now, on the other hand, you also could look at 4 plus, oops, that's the same one. 4 plus 6 plus 3, where you would do the 4 and the 6 first. And I'm going to do that down below. 4 plus 6 gets you right there. You see that the picture is looking different. It is definitely a different picture, but we will end up in the same place. You do the 4 plus 6 first, and then you go 3 more, and lo and behold, you end up at 13 again. So the manipulatives are great for just exploring addition properties and counting. Let your kids play with these a lot and just explore on their own different possibilities. And then they can also be used to illustrate these important properties of whole number addition.